Our next chapter is numerical methods. This is a very small chapter and every year you can expect at least 1 to 2 marks questions from this chapter. So these are the list of topics that we have to learn in this chapter. First we'll start with solution of algebraic and transcendental equation. See, the meaning of this transcendental equation is if we have an equation which involves more than one function. For example, suppose if I have this equation x minus cos x equals to 0. So this is a very simple equation, but you can see that it has two different functions. One is this x, which is algebraic function, and another is cos x, which is trigonometric function. So whenever we have more than one type of function in a single equation, then those equations are called transcendental equation. So first we have to learn solution of algebraic and transcendental equation. In algebraic equation also we know how to solve a linear equation or quadratic equation, but whenever we have an equation whose degree is more than 2, for example quadratic or biquadratic means polynomial equation of fourth order. So if we have algebraic equation of order more than 2, then we have to rely on these numerical methods. For example, suppose if we have to solve a cubic equation, say x cube plus x square minus x minus 1 equals to 0. Now in order to solve this equation, there is two approaches. One is we have to find one linear factor, and then we have to find we know how to solve this equation. We have learned how to solve these type of equation in class 9-10. First we find one root by hit and trial method. If x equals to a is a root, then it means x minus a will be one of the factors. Then we find the quadratic factor and solve this equation. But on many occasions you will find that it is not possible to find one linear factor of this cubic equation, and then we have to rely on numerical methods to solve these type of equations. So basically there are 4 different techniques to solve algebraic and transcendental equation. The first one is bisection method. This is a very basic method. We'll see how to, what are the approach in bisection method. Then second method is Regula falsi method. Third one is secant method. These two methods, Regula falsi method and secant method, are almost similar except for one difference. Then our fourth method will be Newton-Raphson method. Sometimes this is also called NR method. Okay, you can either call Newton-Raphson method or NR method. In GATE, most of the questions are asked from this Newton-Raphson method. Then after that, this will be our first topic, solution of algebraic and transcendental equation. Here we'll learn these 4 different techniques. Then our second topic will be numerical integration. Numerical integration is basically used to evaluate the value of definite integral. Suppose if we have to evaluate this integral, integration a to b fx dx, and many times we find that this fx is not integrable function. For example, suppose if I have to evaluate, say, integration 1 to 2 e to the power x square dx. Now it is not possible, it is not always easy to integrate these type of function, and there we have to rely on numerical integration technique. Here we will see 3 different methods. First one is trapezoidal rule, Simpson's 1/3 rule, and Simpson's 3/8 rule. After that we'll come to this numerical solution of ordinary differential equation. This will be our third topic. So ODE means ordinary differential equation. So here we have to learn 3 different methods. First one is very basic method. This is called Euler's method. Then second one is modified Euler's method, or we call this as RK2 method or Runge-Kutta method of second order. Then we'll come to this RK4 method. So these are the 3 topics that we have to learn. So first we are going to start with this bisection method. Now, so our first method is bisection method. Now this bisection method is based on this basic principle. The principle is that if y equals to fx is a continuous function, continuous function simply means that there is no break in the graph of that function. So if y equals to fx is any continuous function, and x equals to a and x equals to b are 2 values of x, such that f of a into f of b is less than 0. Okay, this simply means that one of these two is positive, other one is negative. If f of a and f of b are opposite sign, then f of a into f of b will be negative. So if this condition is satisfied for any function and any 2 point a and b, then the result is that there must be at least one root of fx equals to 0 in this interval ab. Okay, if this condition is satisfied, f of a into f of b is less than 0, this means one of these two is positive, other one is negative. Then there must be at least one root of fx equals to 0 in this interval a to b. Now let me explain this thing with the help of graph. Suppose if f of a is negative, say if f of a is negative and f of b is positive, and say a is less than b. So what is the meaning of this thing? This simply means, suppose this is your x-axis and this point is x equals to a and this point is x equals to b. Now if f of a is negative, this means when x is a, the value of y will be negative. And similarly, if f of b is positive, this means when x is b, the value of y will be positive. So this is one point a on the graph of y equals to fx, and this is another point b. If you want to write the coordinate will be x is b and y is f of b, and here x is a. At this point x is a and the value of y is f of a. So now these are the 2 points on the graph of this function y equals to f of x, and at a you have negative value, at b you have positive value. The graph is continuous, so this means if you want to join these points, there must be at least one point where the graph will cross the x-axis, and this is the point where the value of f of x will be 0, and hence this will be the root of this equation fx equals to 0. So whenever this condition is satisfied, then there must be at least one point between a and b where f of x will be 0, and the point where f of x is 0, the value of x at that point, that will be the root. Okay, so this is the basic principle behind this bisection method. Now we are going to see what is the procedure to solve any equation using this bisection method. So our aim is we have to solve this equation fx equals to 0 and the interval that is given is a to b. Now the procedure will be, suppose if f of a is negative and f of b is positive, it can be other way around also. At one point you should have negative value, at other point you should have positive value. Now our first approximation will be x1 is simply a plus b by 2. Okay, see in numerical method we are never going to find the actual root, we will always find the approximate root of that equation. Okay, so our first approximation will be a plus b by 2. At a we had negative value, at b we had positive value. So we are trying to find out what should be the first approximation. So this will be simply a plus b by 2, meaning that after first iteration we can say that this x1 is the root. X1 is approximately the root. Now if we want more accuracy, so if we want to find the next approximation, then we have to find f of x1. Okay, we have to calculate the value of the function at this point x1, and now there are three possibilities. The first possibility is that f of x1 is 0. This case will rarely get, but suppose if f of x1 is 0, this means x equals to x1, this will be the root. Okay, root means we have to find that value of x for which fx becomes 0. So if f of x1 is 0, this means x1 is the root. Second possibility is f of x1 is negative. Now if f of x1 is negative, then in that case you have to replace a by x1, right? F of a was negative, now we are getting f of x1 as negative, so you have to replace a by this new value x1. And the third possibility is f of x1 is positive. Now in that case you have to replace b by x1 because f of b, this was positive. This we will see with the help of one example. Now for the next approximation, again x2, this will be a plus b by 2, but now you have to use the new value of a and b. Okay, so this will be the formula to calculate second approximation, a plus b by 2, and the general iterative formula will be xn plus 1. This will be xn plus xn minus 1 by 2. So these are the steps that you have to follow in bisection method. Now we'll take one example and we'll see how to apply these concepts. Okay, so our first problem on bisection method is find the root of this equation fx equals to x cube minus x minus 1 equals to 0 in this interval 1 to 2 using bisection method in 3 stages. In 3 stages simply means we have to find the value of x3. So here the fx that is given to us is x cube minus x minus 1, and the given interval is 1 to 2. We have to find the root of this equation fx equals to 0 in this interval 1 to 2. Now if we calculate f of 1, this will be 1 cube minus 1 minus 1. So this will be minus 1 negative. So at 1 we are getting negative value. F of 2, this will be 2 cube minus 2 minus 1. So this will be 5 positive. So at 1 we are getting negative value. At 2 we are getting positive value, and this simply means that there must be at least one root of fx equals to 0 in this interval 1 to 2. Now our first approximation will be, for the first approximation x1, this will be simply a plus b by 2. A is 1. Okay, the first point is 1, the second point is 2. So this will be 1 plus 2 by 2, 1.5. So after one iteration, you can say that the root of this equation will be approximately 1.5. Okay, as I have said earlier, in numerical method will not get the exact root but approximate root. So after one iteration or after first approximation, you can say that the root will be approximately 1.5. Now if you want to find the second approximation, then you have to calculate f of x1. So for second approximation, if we calculate f of 1.5, this will be 1.5 cube. This is our f of x. So now in place of x we have to write 1.5. So this will be 1.5 cube minus 1.5 minus 1. Now if you do the calculation, you will find that this value will be positive. Okay, you can use the calculator and find this value. You will find that this value will be positive. So now you can say that at 1 we are getting negative value, at 1.5 we are getting positive value. So this means the root of this equation must lie between 1 and 1.5. Okay, earlier for the first approximation we found that f of 1 was negative, f of 2 was positive. So this means the root was between 1 and 2. First approximation was simply 1 plus 2 by 2, 1.5. Now for the next approximation we calculated f of 1.5 and this will come out to be positive. Now if f of 1.5 is positive and f of 1 is negative, this means now the root will be between 1 and 1.5. So for the second approximation, I can write the second approximation here. So for the second approximation, x2, this will be simply 1 plus 1.5 by 2. Okay, because at 1 we are getting negative value, at 1.5 we are getting positive value. So this will be 1.25. So after 2 iteration we can say that the root is approximately 1.25. Now note, remember that this is not exact root. Okay, this will be only the approximate root. So after first approximation we can say that root is approximately 1.5. After second approximation we can say that the root is approximately 1.25. Now if we want to calculate the next approximation, we have to calculate this f of x2. This means f of 1.25. So this will be 1.25 cube minus 1.25 minus 1. Now if you perform the calculation, then you will find that this value will be negative. Okay, so now f of 1.25 is negative and this means the root will be between 1.25 and 1.5. Okay, because earlier we were getting at 1 negative value, at 1.5 positive value, so root is between these two numbers. Now we are getting that at 1.5 the value is positive, at 1.25 the value of f of x is negative. So this means the root must be between these two numbers, 1.25 and 1.5. So for the third approximation, x3, this will be simply 1.25 plus 1.5 by 2. Now if you do the calculation, this will be 1.375. So after three iterations, you can say that the root is approximately 1.375. So this will be the answer. X3 is 1.375. Now if you want to see this concept from number line, then the point that were given to us was 1 and 2. Okay, these were the 2 points that were given to us. One point was x equals to 1, other point was x equals to 2. And we had to find the root of this equation fx equals to 0 between 1 and 2. We had calculated f of 1, this f of 1 was negative, f of 2, this was positive. So for first approximation, we calculated the midpoint of these two, midpoint of 1 and 2. So the midpoint of 1 and 2 will be 1.5. Now we calculated f of 1.5. This value was positive. So now at 1 you had negative value, at 1.5 you had positive value, and so the root must be between these two numbers, 1 and 1.5. So now we calculated the midpoint of these two. The midpoint of these two will be 1.25. We calculated the value of f of 1.25 and this value was negative. So now at 1.25 we had negative value, at 1.5 we had positive value. So now we are going to calculate the midpoint of these two, 1.25 and 1.5. So the midpoint of these two will be 1.375, and since we had to solve only up to 3, we have to solve in 3 stages. This means we have to find only x3. So x3 will be 1.375. So this is the idea behind this bisection method. This is very basic method. You can always get a root of fx equals to 0 using bisection method. But there is one disadvantage from this method, that this method is relatively slow compared to the other 3 methods. So we'll take one more problem on this bisection method and then we'll talk about secant method. Our next problem on bisection method is, this question was asked in GATE 2012 in civil engineering. So the question is, the bisection method is applied to compute a 0 or root is the same thing. So bisection method is applied to compute a 0 of this function fx is x to the power 4 minus x cube minus x square minus 4 in the interval 1 to 9. Okay, this interval is given, this function is given. It is said that bisection method is applied to compute a root of this equation fx equals to 0. The question is, the method converges to a solution after how many iterations? And the options that are given to us is 1, 3, 5 and 7. Now our f of x, this is x to the power 4 minus x cube minus x square minus 4. We have to compute the root of this equation and the given interval is 1 to 9. Now first we are going to calculate f of 1. This f of 1 will be 1 to the power 4 minus 1 cube 1 to the power 4 minus 1 cube minus 1 square minus 4. Now this obviously is negative. Then we have to compute f of 2. F of 2 will be 2 to the power 4 minus 2 cube, not f of 2 but f of 9. The second point is b is 9, so this means we have to calculate f of 9. So this will be 9 to the power 4 minus 9 cube minus 9 square minus 4. In place of x we have to substitute simply 9. So this value, as you can see, this will be simply this will be positive, because 9 to the power 4, this will be a very large number. We are subtracting these from 9 to the power 4. So we'll get some positive quantity. This you can verify using calculator. So f of 1 is negative, f of 9 is positive, and this means our first approximation will be, for the first approximation we have to simply take the midpoint of these two. So this will be 1 plus 9 by 2, 10 by 2, this will be 5. So after one iteration you can say that the root is approximately 5. But the question is, the method converges to a solution. This means we'll get exact solution and we have to find the number of iteration after which we'll get exact root. So now for the second approximation we have to calculate f of x1. So f of x1, this will be f of 5. This is your expression for f of x. Now in place of x we have to write 5. So this will be 5 to the power 4 minus 5 cube minus 5 square minus 4. Now again this will be 625 minus 125 minus 25 minus 4. So this will come out to be positive. So now for the second approximation, as you can see, f of 1 is negative, f of 5 is positive. So this means the second approximation x2, this will be 1 plus 5 by 2. So this will be 3. So after 2 iteration you can say that the root is approximately 3. Now for the next iteration we have to calculate this f of x2. We have to find this f of 3. So this will be 3 to the power 4 minus 3 cube minus 3 square minus 4. Now if you do the calculation, this will be 81 minus 27 minus 9 minus 4. This will be positive. So for the next approximation, for the third approximation, we have to calculate the midpoint of these two numbers. At one point we should have negative value, at other point we should have positive value. So at 3 you are getting positive value, at 1 you are getting negative value. So this means our third approximation x3, this will be 1 plus 3 by 2, which is 2. Now for the next approximation we have to calculate f of x3. F of x3, this will be f of 2, 2 to the power 4 minus 2 cube minus 2 square minus 4. So this will be 16 minus 8 minus 4 minus 4, which is 0. So as f of x3 is exactly equal to 0, this means x3 is the root. If f of x3 is 0, this means the root is x equals to x3, and the value of x3 is obviously 2. So we are getting the actual root after 3 iteration. Okay, We are getting the actual root after 3 iteration, and this means the method converges to a solution after 3 iteration. So the correct answer for this question will be option B. So this was very simple question. Once you know the concept, then you can easily solve these type of problem. In bisection method, you always have to see that you should take 2 points. At one point the value of function should be negative, at other point the value of function should be positive. Okay, if you want to see this in graph, then we had to find, if you want to see this in number line, then we had to find the root between 1 and 9. So first we calculated. Now f of 1, this was negative, f of 9, this was positive. We calculated the midpoint of 1 and 9, so this will be 5. At 5 we were getting positive value, so this means at 1 negative, at 5 positive, we have to calculate the midpoint of these two. The midpoint will be 3, and f of 3, this was again positive. So this means now we have to calculate the midpoint of 1 and 3. Midpoint of 1 and 3 will be 2, and f of 2, this was exactly equal to 0. So this means we are getting actual root after 3 iterations. Okay, so these were the 2 problems on bisection method. Now we are going to talk about our next method for solving algebraic and transcendental equation. So our next method was secant method. Our next method is Regula falsi method. This Regula falsi method and secant method are almost similar. There is one difference that we'll see after learning this method. So in Regula falsi method also we have the same aim. We have to find the root of fx equals to 0. The given interval is a to b. At one point the value of function is negative. Suppose f of a is negative and f of b, this is positive. Now here we have to find the formula for the first approximation x1. We'll see how to derive this formula. In bisection method, x1 was simply a plus b by 2. Here we'll have some different formula. Then other steps are similar to bisection method. Once we have calculated x1, then for the second approximation we have to find f of x1. There are 3 possibilities. The first possibility is f of x1 is 0. This means x equals to x1 is the root. The second possibility is f of x1 is negative. In that case we have to replace a by x1 because f of a was negative. Now if f of x1 is negative, then replace a by x1. And the third possibility is f of x1 is positive. In that case we have to replace b by x1. And then again we have to, for the second approximation, we have to follow the similar approach. So first we are going to find out the formula for this x1. Now in secant method what happens, first let me explain the basic idea of this secant method. Say these are the 2 points a and b. This point is where the x is a and the value of y is f of a. Since f of a is negative, therefore I have taken this point below x-axis. And the second point is x equals to b, and at b the value of function is positive. This height will be f of b and this height will be f of a. Since f of a was negative, point a is below the x-axis and f of b is positive, therefore point b is above this x-axis. Now suppose if this is the graph of this function y equals to f of x. Okay, this is the graph of function y equals to f of x. Now the point where this graph is crossing the x-axis, this is the actual root. This is the actual root I will represent by alpha. So this is the actual root that we are trying to find out using iterative method. So in bisection method we were simply calculating the midpoint of these two. We were calculating the midpoint of these two numbers a and b. Midpoint was a plus b by 2. In Regula falsi method what we do, that we join these 2 points a and b by a straight line, and the point where this chord AB, okay, this line AB will cross x-axis, this will be our first approximation x1. Now in the next iteration what we will do, that we will find the corresponding point on the curve. Say this point is the corresponding point. So now we will join these 2 points. Here the value of function is positive, here negative. So now we are going to join these 2 points by a straight line, and the point where this line will cross the x-axis, this will be our second approximation x2. And in this way we will reach closer and closer to the actual root. The actual root is alpha. First approximation was x1, second approximation will be x2. Now you can see that this x2 is very close to the actual root alpha. If we want more accuracy, then we can perform more number of iteration, but we have to follow the same approach. In the next iteration we will find the corresponding point on the curve, join these 2 points by a straight line, and in this way we will get close and close to the actual root. So now our aim is, we have to find the value of this x1. We have to find the formula to calculate the first iteration x1. Now see, it is very easy to find the formula for x1. This x1 is nothing but the point of intersection of line AB with x-axis. So first we are going to write the equation of this line AB, and the point where this line AB will cross the x-axis, that will be our first approximation, x1. So if we want to write the equation of this line AB, we know that the equation of line in 2-point form is y minus y1 y2 minus y1 by x2 minus x1 into x minus x1. This portion is the slope of line, so y minus y1 m into x minus x1. This will be m, slope of the line. So similarly here also we have these 2 points. One point is a f of a, this is x1 y1, and another point is b f of b, this is x2 y2. So if we want to write the equation of this line AB, then equation of the line AB will be y minus y1, and this equals to y2 minus y1 by x2 minus x1 into x minus x1. This will be the equation of line AB, y minus y1 m into x minus x1. Now in this line, the point where this line is crossing the x-axis, at that point the value of y will be 0 and the value of x will be x1. So we can write that when x is x1, the value of y is 0. So in this line now we are going to substitute these points. In place of x I will write x1, and in place of y I will write 0, because this point is lying on this line and therefore it must satisfy the equation of this line. So I will get 0 minus f of a, and this will be f of b minus f of a by b minus a. In place of x, in place of x1 we should write a here, because x1 is a, right? Y minus y1, y1 is f of a, x1 is simply a. So now this will be x1 minus a. Okay, y minus y1, in place of y we have 0, slope of the line f of b minus f of a by b minus a. In place of x I have written x1, and this was the first point a. So now if you rearrange this relation, this you can do on your own. If you rearrange this, then you will find that x1 will be a f of b minus b f of a by f of b minus f of a. So this will be the formula to calculate the first approximation x1. Now how to remember this formula? It is very easy to remember the formula. See, a f of b means we are taking the x coordinate of first point and multiplying this with y coordinate of second point, minus x coordinate of second point multiplied by y coordinate of first point. So x of first, y of second, minus x of second, y of first. And in denominator you can see that y is in the same order. In numerator also you have f of b minus f of a. In denominator also you have f of b minus f of a. So this will be the formula to calculate the first approximation x1. x1 will be simply a f of b minus b f of a by f of b minus f of a. So this will be the formula for first approximation. Once you have calculated the first approximation x1, then other steps are similar to bisection method. And here the general iterative formula will be xn plus 1. This will be x of first point, y of second point. So xn minus 1 yn minus x of second point, y of first point. So xn yn minus 1, and this divided by, in denominator y will be in the same order, so yn minus yn minus 1. You can do one thing to avoid any calculation mistake. Always write y inside the bracket. So in this way you know that in denominator you have to write yn minus 1, because these will be some numbers. So when you are performing the calculation, there is possibility that you may get confused. So always write y inside the bracket, and in that way in denominator you will not have any confusion. You have to write yn minus 1. So now we will take one problem and we'll see how to solve any equation using this Regula falsi method, and we'll also see what are the modification in secant method compared to Regula falsi method. So our first problem on Regula falsi method is, this method is also called method of false position. So the problem is we have to find the root of this equation fx equals to x cube minus 4x equals to 0 in the interval 2 to 3 using Regula falsi method in 3 stages. This means we have to find x3 here. So first step will be we have to calculate f of 2. So this f of 2 will be fx is x cube minus 4x minus 9. So f of 2, this will be 2 cube minus 4 into 2 minus 9. 2 cube will be 8, 8 minus 8 0, so this will be simply minus 9. F of 2 is negative. Then we have to find f of 3. So f of 3 will be 3 cube minus 4 into 3 minus 9. So this will be 27 minus 12 minus 9. So 12, 9, 21, 27 minus 21, 6. So this will be positive. Remember that in case of bisection method, it was sufficient to find whether this value is positive or negative. Here we need f of 2, f of 3, because in the formula for x1, we will need the value of y at these 2 points. So now for the first approximation, we have these 2 points. Okay, when x is 2, the value of y is minus 9. So one point is x2, y minus 9. And another point is when x is 3, the value of y is plus 6. So another point is 3, 6. Now the formula for x1 was a f of b minus b f of a by f of b minus f of a. So here if we want to write the formula for x1, the expression for x1 will be, we have to write x coordinate of one point, y coordinate of another point. So this will be 2 into 6, always write y inside the bracket, minus x of second, y of first. So this will be 3 into minus 9, and this divided by 6 minus minus 9. This will be the formula for x1, x coordinate of first point, y of second, minus x coordinate of second point, y of first, and in denominator we have the y coordinate in the same order, 6 minus minus 9, here also 6 minus minus 9. Now if you do the calculation, you will find that this will be 2.6. So our first approximation x1, this will be 2.6. Okay, now for the next approximation, we need to calculate the value of f of x1. So f of x1, this will mean f of 2.6. Now this is your expression for f of x. So this will be 2.6 cube minus 4 into 2.6 minus 9. Now if you do the calculation, you will find that this number will be minus 1.842. After calculation, you can find that this f of 2.6, this will be minus 1.824, and this value is negative. So for the next approximation, for second approximation, we need to find, we need to use those 2 points. At one point the value of y is positive, at another point the value of y is negative. So as you can see, at 3 we are getting positive value, and at 2.6 we are getting negative value. So now the point that we need to use is, one point x is 2.6, y is minus 1.824, and another point is when x is 3, the value of y is plus 6. So this will be 3, 6. So these are the 2 points that we need to use for the next approximation. Always make sure that the value of y coordinate at one point should be negative, at other point it should be positive. So now the formula for x2 will be x coordinate of one point, y coordinate of another point. So 2.6 into 6 minus x coordinate of second point, y coordinate of first point. So minus 1.824. And this divided by y coordinates will be in the same order. So this will be the expression for x2. X, y, x of first, one y of another, minus x of second, y of first, and denominator y coordinate in same order. Now here if you perform the calculation, you will find that this number will be 2.693. Okay, so this means the value of x2 will be 2.693. So after 2 iteration, you can see that the root will be 2.693. But the question is, we have to find the solution in 3 stages. We have to find the value of x3. So we need to perform one more iteration. Now for the next iteration, we need to calculate the value of f of x2. So f of x2 will be, this is your expression for f of x. So f of x2 means f of 2.693. So this will be 2.693 cube minus 4 into 2.693 minus 9. Now if you do the calculation, you will find that this number will be minus 0.241. This will be the value of f of x2. Now again f of x2 is negative, f of 3 this was positive. So for the next approximation, for third approximation, the point that we need to use is, one point will be x is 2.693 and the value of y is minus 0.241, and another point will be, now see at 3 we are getting positive value, at 3 the value of y is plus 6, so this means the another point will be x3 y6. So these are the 2 points that we need to use to find the third approximation. Always see that at one point the value of y is negative, at other the value of y is positive. Here also same thing. So now for the third approximation, x3, this will be x of first multiplied by y of second minus x of second y of first, and this divided by y coordinate in the same order, so 6 minus 0.241. Okay, now again if you do the calculation you will find that this number will be 2.70. So after 3 iteration you can say that the root is approximately 2.70. So this will be the answer, 2.70. And also you can see that there is very little change in second and third approximation. Second approximation x2 was 2.693 and the third approximation x3 is 2.70. So since there is very small change between these two numbers, so this means we are very close to the actual root. Now, so this was Regula falsi method. Now we are going to see what is secant method and what is difference between Regula falsi method and secant method. So secant method is, it is similar to Regula falsi method. It is similar to Regula falsi method. Regula falsi method is also called method of false position. So it is similar to Regula falsi method, except means this is the difference between these two methods. So except that always last 2 points are used for next approximation. So this is the basic difference between secant method and Regula falsi method. In secant method, always the last 2 points are used for the next approximation. Now let me explain this thing with the help of this example. Suppose if this point was A and this point was B. So for the next approximation, we are using these 2 points. This will be same in Regula falsi method and in secant method. Now the next point that we obtained was, this point was C, right? This point was, the next point that we obtained was x was 2.6 and the corresponding value of y was minus 1.824. Now in Regula falsi method, we are making sure that at one point the value of y is negative, at another point the value of y is positive. But in secant method, we don't worry about that positive negative thing. We always have to take the last 2 points for the next approximation, meaning that for the next approximation x2, we are going to use these 2 points. One point will be B and another point will be this C. Okay. Now the next point that we are going to get is, at x2 was 2.693 and this was the corresponding value of y. So this point that we are getting is, say that point D is 2.693 and the value of y is minus 0.241. So in this secant method, for the next approximation x3, we are going to use these 2 points C and D. You can see that at both of these points the value of y is negative, but still we are going to take these 2 points for the next approximation. So that is the difference between Regula falsi method and secant method. The formula will be same. The formula to calculate the approximation x1, x2, this will be same. But the point that we are taking in Regula falsi method and in secant method may be different in some cases. For example, here for x1 we are getting the same point, but for the second approximation, the point that we had to use was point B and C. Okay. The first 2 points are A and B, then we obtained this point C. So for the next approximation, we have to use these 2 points B and C. Now the next point that we are getting is this point D. So for the next approximation, now we have to use these 2 points C and D. So that is the difference between secant method and Regula falsi method. Now remember that Regula falsi method is better than secant method, because in secant method sometimes we may not get the actual root, but in Regula falsi method we will always get the actual root, because we are making sure that we are always taking 2 points. At one point y is positive, at another y is negative, and this means between those 2 points there must be at least one root of fx equals to 0. So after this we have to talk about Newton-Raphson method, which is the most important method, and most of the questions which are asked in GATE exam are based on this Newton-Raphson method.